All right, so we have been looking at deterministic models where you find the x's, you try to put the x's in the scenario, and you generate your x's. Okay, that has been the normal thing. See, they reflect, certain information. But there are situations where information is not certain, it's probabilistic, it's stochastic. And we are going to look at probability. This is a topic which most undergraduates would normally look at. But we're going to look at the three main kinds of probability: binomial probability, Poisson probability distribution, and normal distribution. Now, majority of people know of the normal distribution. So first, I want to give you the intuition, because sometimes as a management science student, some wonder why you have to study probability. They think that probability is for the statistics students. Well, it's not only for them. Everything, and you're going to see examples, hinges sometimes on probability. The conclusions we make about hypotheses will depend on the sample we take. The sample we take will lead us to a wrong conclusion. NDC will win the next election. You are making a probable statement. Okay. How do you come out with that conclusion? Obama will lose the election. Trump will win the Senate case against impeachment. Okay, we make statements just like that. But we need to know what the chances of such a statement are happening. And that's why we study probability. It has to do with chance of an event occurring. Okay, the chances of an event occurring is what we call probability. So let's take an experiment in any situation. Now, when you have an experiment in any situation, the outcome of that experiment is called an event. And this outcome is not certain. A typical example is drawing a card from a deck of cards. What is the probability that I'm going to get the queen of cards, the king of cards, the jack of cards? It's uncertain. And so we say it is likely, it is probable. Okay. And the probability of it happening is always said to be equal to 1. Okay. And if the probability of it happening is equal to 1, then the probability of the event not happening is 1 minus the probability of the event happening. I'm sure you know these already. Always know that probability is between 0 and 1. This is an important thing that we all know. It's between 0 and 1. So all the answers you're going to be getting are between 0 and 1. Let's take an example, and then you find the probability for me. Let's consider an event of rolling a dice. If you toss a dice, there are 6 sides to the dice, with each side showing one number: 1, 2, 3, up to 6. Now, what is the probability of the number 6 occurring? Type the answer in the chat for me. What is the probability of the number 6 occurring? How would you calculate that? What is the probability of number 6 occurring? Steven says it's 1/6. Let me see the rest. Michael, Janet, McClare. McClare has actually put it into decimals even for us. Okay, so that is 1/6. Okay, very good. That's good. Okay, so that is one particular instance, and you are all right, by the way. Okay, now in probability we talk a lot about mutually exclusive events, disjoint events. Okay, 2 events that cannot happen at the same time. That's a mutually exclusive event. So if you look at this event A and this event B, there is no intersection. So the probability of A or B is the sum of them. It's a probability of the sum of them. Okay, these are the easy probabilities that we used to learn. Okay. Now, but non-mutually exclusive event means that one cannot happen without the other happening. So they are more or less intertwined. So if you look at M or F, the probability of, M or F is going to be the probability of M plus the probability of F plus the probability of the intersection of M and F. That's a joint probability. So it's a probability that 2 or more events are not mutually exclusive, or they can occur simultaneously. Okay, so this is where you have an intersection. But when you don't have an intersection, then it is mutually exclusive. They can't happen at the same time. You can't be going to the US and be going to America at the same time. Okay, that's mutually exclusive. Let's take a typical sample question on probability. Okay, we are building on gradual to have a point. The Dean of the University of Ghana Business School analyzed the records of 3,000 students. They have received a grade in management science during the past 4 years. 3,000 students. They didn't want to know the number of students who made each grade in the course. Now, the Dean staff has developed the following table of information. So there you go. The first event are the event of those who got a grade A, and they are 300. Those who got grade B are 600. Those who got grade C are 1,500. Those who got grade E, 450, and those who failed, 150. What is the first thing you've got to do, looking at this quick scenario, before we even come to the question? What is the first thing you have to do? You can tell us. The very first thing. Okay. So Steven's hand is up. Steven, let me give you the opportunity to tell us.
Okay.
What is the first thing to do? Yes.
Look, I think the first thing we can do from this table is to strike the total.
Perfect answer. So that's the first thing to do. Get a total. Get a total. Okay. So let's get a total. And this is a total. The total is 3,000. 3,000. Now, go back to the question. The dean want to know the number of students who made each grade in the course. Okay. So we know. So what is the probability that a student got an A? What would the answer be? What would be the probability that a student got an A? What is the probability? You can type the answer there. What is the probability that a student got an A? Excellent answer from Ebenezer, 1/10 from Eunice, 0.1 from Precious. I like the way some of you are giving beautiful answers. Okay, so that is 300/3,000, and then that's it. And what is the probability that a student got an F? What is the probability that a student got an F? Who is the first to give the answer for that? 0.1, Janet, excellent. Okay, so the question I asked you is the probability that a student got an A, that's what you all get, the marginal probability. Okay, what is the probability that a student got an F? That's what you all get. Okay, 0.05. That's what Mark Claire said. Now, what is the probability that a student gets A or B, but not both? Now, I looked at that situation some few minutes ago. What is the probability that a student gets A or B, but not both? The student gets A or B, but not both. Let me take you to the board. Okay. What is the probability that a student gets A or B, but not both? Now, but not both is an important thing. Okay. Because if you don't have but not both, you will not be able to know the best way to go. So the probability that a student gets an A or B. First of all, the probability of a student gets an A or B is going to be, nobody has got it yet, probability of A plus the probability of B. Okay, but not both. So you don't have to do minus the other one. That is it, but not both. But not both be, okay, if he had not said but not both, we would have brought the intersection into it. Okay. So what is the probability of a student getting an A? Most of you gave the answer earlier on. That was what? That was 0.1. And what was the probability of a student getting a B? Do you remember? Okay. Who guessed that? If I let me show you the screen. There's probability that a student gets a B. B is 600, by the way. The probability of a student getting a B is what? 1/5. So that's 0.2. Okay. So we go back, we now do our 0.2. So the probability that a student gets A or B, but not both, is going to be 0.3. And that is how you execute these probabilities. Okay. That's it. Let's go back. So that's 0.3. Now let's take another example. Let's try to learn how to model, describe the process of taking a sample. So let's assume that we are going to take a sample, okay? We're going to take a sample, and the sample is N from a bigger population size sample of N. Now, since there are many different types of data and many different ways we might collect data sample, we need to understand the different probability models to do that. One of the probabilities we want to look at is the binomial distribution. It is one such model that turns out to be very useful in real life. Binomials. There are several situations that are binomial. Okay, there are several situations that are binomial. So we are going to take up the binomial situation.